Welcome everyone to Robot Builders Night Virtual for March 18th, 2025. And we've got a usual agenda, some DPRG announcements, a queue of people with things to show or talk about, and then open mic. So DPRG announcements. I want to remind everyone that the monthly meeting is this Saturday, and I just am tickled pink by the graphic that Mark made for this talk. It's about ROS2 navigation and Lino Robot 2. And how the two intersect, but I just think this is the coolest graphic. So thank you to Mark on that. So anyway, the talk is going to be about why do we care about ROS2 navigation, and why Lino Robot 2? What is Lino Robot 2? And then Ross's navigation concepts, and how to configure your robot as a Lino Robot 2. So in a nutshell, that's it. And then on the following Sunday, for people in the DFW Metroplex area, we'll have a robot power lunch at Ford's Garage. Ford's Garage is a really cool place that Carl introduced me to, and we'll have a semi-private area there, where we'll have waiter service, and everyone is responsible for their own tab. But it was pretty fun last time. People wanted to do it again, so we're doing it again. And then the last thing I want to mention is, and I don't think Trish is here, and let me just check the calendar, because pretty soon we have an opportunity to help some of Trisha's folks with their interview practice. So let's see, I don't quite see. Yeah. So this Sunday, I figured I'd send out email to the list and look for volunteers. But I'll mention it here and call for volunteers for anyone who's available to help some of Trisha's first robotics competition folks practice their presentation. So this is part of the VEX Robotics contest, and so it's a different thing than Kareem's first tech challenge contest, but kind of similar in a lot of ways. The robots are bigger, more expensive, and she's got 3 teams that want to practice their interview. The interview process works a little differently than it does in FTC, but I think if we can fit in a couple of interviews with each of the 3 teams, give them feedback after the first interview, and then let them practice and come back and do it again and see how it goes. I thought that'd be really a nice thing for them. So if anyone's available to help with that, I would certainly appreciate it, and I know Trish would too, and the students would as well. There's a standard set of questions that we can ask, and a rubric that we can evaluate their responses by, and then we'll give them feedback, kind of like what I did with Kareem's one of Kareem's teams one time. So,
not that it matters that much, but you're confounding a couple of the competitions. So first is both FTC and FRC. So FRC is the big ones, the bigger ones. And then there's FTC, which is what my teams do. And then VEX is in the same size category as what my teams do. But different
you're right. I
stuff, but it's okay. It's not that big of a deal.
Kareem,
We all need support.
Yeah, I totally had a senior moment. Yeah, this is VEX. I don't know where I got. I know I got FRC from Sanrat, who joined the meeting last week and got that stuck in my head. But yeah, Trish herds, I think, 5 robot teams. So sort of like what you do, Kareem.
Right.
You know, herding multiple teams and trying to coach them, and so anyway, it's an opportunity to help out with that. So,
Paul, you should mention that it's going to be virtual, so it's not just limited to people in Dallas.
Yes, thank you, Doug. Yep.
So anybody who wants to sit in a session and see what it's like, and they don't have to even say anything if they don't want to, but if they, see something real obvious, they might want to join in. And so it can be anybody in that usually comes to Robot Builders Night virtual. It'll be similar to Robot Builders Night virtual in the sense that it's virtual. The team will just present, and then at the end or during, or depending on how they want it done, we'll ask questions and then do feedback.
And likewise, the robot power lunch isn't exclusive to Dallas. So, Chris, Pat, Tom, it's Trek time.
Absolutely right, Kareem. You're muted, Tom.
Just need one of those teleporters,
Yeah. I'll have a virtual meal, I guess.
Yeah. Unfortunately, virtual attendees will not be supported at the robot power lunch. But Kareem, I hope you can make it out this time. It's a little closer to you, not a lot, but a little.
Yeah, I should be able to this time.
Awesome. So anyway, all right, that's my pitch for. So you can let me know offline or whatever about if you're available to help out with the VEX interviews. So first up, Mike.
Okay, well, I've just been working on my little robot, and so I'm going to show my GitHub that I'm building up for it. So let's see. Where is it? So can you see the GitHub?
Yep.
Okay. And I was wondering if anyone else can see it, because when I go to my site, I don't see it here on this landing page. But if I go to my repositories, it shows up right here.
Yeah, that's always the way it works. More recent stuff will only show up in the full list until it's been visited by a lot of people.
Oh, okay. Okay. Yeah, so because I put it on public, so it should be visible. So But yeah, so I've been putting it together, and I decided I'm going to just put everything in my GitHub. I got the 3D printing information, which is basically all of the files, all the G codes and the design files, and then there's also the Arduino code, because I got two microcontrollers. So I got the front sensors and the wheel controller, and so this is where I put the Arduino code in, and then I put my source port information, which is basically schematics and pictures stuff, and then this is the README file. So this is where I was trying to do the information here. So it's got a picture of my robot, and so I think I showed this yesterday, basically, or I mean last week, and so like here's a power supply module, and this is the Pi, and then the wheel controllers back there, and the sensor controllers here, and then I got a camera and a LiDAR, and I plugged those into a powered hub, which gets powered by the power supply, so it loads the Pi, and then I got my laser pointer to be able to see what's point to something straight ahead of me. So I for testing, I put a can right there and test it out. And then I have tucked away under the bottom here, I have an IMU, and then I have my current sensor here, battery sensor, voltage and current, and I have a single point range detector. It's a VLC 53, a VL53L4, and it just sees what's in front. And then right here I have the two sensors. They're both 45 degree sensors on here, which are 8x8 each. And so I mounted them 45 degrees relative to each other, so it becomes a 90-degree sensor. And I got one on both sides, and they point out, so it gives me a really good range for low-level obstacle detection at low levels. The range right here is taller than the cans, so it's going to be for localization, and then these are going to be for obstacle detection and to help maneuver into a can. And then the can, this is the limit switches to know when the can's been grabbed. And of course you can see the wheels. And the bottom here is the servos, and then these are my grippers. They go and they close and pull the can into the limit switches, into that notch there. And then I have the motors and the wheels, and then the battery and a caster. So that's basically my hardware design. I've shown it before, but this is nice pictures, and it's in a document.
Oh, nice.
And then this is like a schematic of the electronics. a block diagram, say, a block diagram.
Where's the Arduino in this diagram, Mike?
Oh, the wheel controller and the sensor controller. It's a RP2040.
Okay.
But I use Arduino IDE to program them, so their code's stored under Arduino.
So there's two of them, the front sensors controller and the wheel controller?
Right. Yeah,
Okay.
that's this controller here. It's that little module underneath that wire. You can't hardly see it.
Oh.
It's a it's a wave share RP2040 which is tiny.
Nice.
And so, yeah, so basically here's the power comes in from the battery. It's about 14 to 15 volts. And then the voltage regulator brings it down to a 12 volt to run the motors on the wheel controller. And then a separate 5 volt regulator output for the Raspberry Pi. And I put the laser pointer on there too. Basically, these are like USB-C connectors coming out for power. And that one had a USB-C for power. And this one had a USB-C for power. Raspberry Pi. And then the other 5 volt regulator is for the wheel controller module and the USB hub and the sensor controller module. So that basically unloads all the power from the USBs coming out of the Pi going to everything. So everything doesn't load down the power on the Raspberry Pi.
You do a nice job of your documentation, Mike.
So these are the things that hook up to the wheel controller, the left and right motor, the left and right claw, and the left and right limit switch. And then the sensors, there's the left 90-degree 8x16 sensor and the right one, and then the center sensor, which has only an 18-degree spread, and then an IMU and the battery. So that's what I was talking to before. And then this was a schematic for the power supply board. So basically the power comes in, switch and a fuse. It has a current and voltage sensor, and then it goes to the 3 regulators, and then I put more capacitors on the output of them, and then I put them on 3 connectors. So it's a pretty simple board. But because the regulators are big, it's a big board. You can see at the beginning that it's about the size of a Pi or something on this side. And then this is the sensor controller board. And what I have it sort of described up here, but it's the RP2040, and the 5 volt comes in, gets reverse voltage protected, or so that the 5 volt from the USB cable doesn't feed into the other modules and stuff. It's pretty important to do that. And then then I have a 3.3 regulator on here because these sensors take a lot of power. So I couldn't use the 3.3 volt output of the RP2040 board. And so this one it powers all the sensors. So it's good. And then this is just the connection to the connectors. And then this is the wiring harness that goes to the 2 left and right sensors. And since they come up default with the same I2C address, there's a, I'm not sure if I can pull this up or not, but there's a it's not letting me blow it up very well. Okay, so there's an enable for each of the 2 boards. So when it comes up, all the boards are disabled, and the power supply, the regulator here gets shut off and shut back on, and that resets the internal sensors to their default I2C address, and then I cycle them up one at a time to set their particular addresses based on that wire. And then this is the wheel controller. So basically it has the RP2040, it has 2 motor drivers, and then it has a level converter. And the level converter was because the encoders on the wheels really didn't want to get down to 3.3 volts. They say they'll work, but I didn't trust them. So I ran them at 5 volts and did a level conversion to get really nice, clean, sharp edges out of them. So, yeah, and then the RB2040 has the PIOs on them, so they make really good pulse width modulated for driving the motors, PWMs, and then they have some really good code for those PIO modules to do the pulse, the PWM driving of the servos also. And then they have good. The PIOs also have good detectors on them for doing the quadrature detection. So all that's run in hardware on the RP2040.
That's a good idea.
So that's pretty good. So that's my README file. Need to add more information to it and keep it up to date. Is there anything on this README file of interest, or?
Just Mike, one question. I notice you have a separate Bluetooth transceiver. Is that correct?
The receiver, that's for the game controller.
So
Joystick.
does your Raspberry Pi 4 support Bluetooth? And why did you choose not to use it?
The game controller came with a little dongle to plug in, so I just used it.
Okay, so you had it, so you used it.
Yeah.
Got it.
That way I didn't have to program it or anything, so I just plug it in and it's happy. and then the ROS Joy module knows about it, and it can decode it and send information to the ROS system for teleop. Yeah, so right now my robot's down in another. Today I just moved to another room, and because I was building the course to do the debugging and testing in a room I'm not using, and I'm realizing that it doesn't have good Wi-Fi, so I got to figure out how to fix that. Because it's pretty unreliable between the Linux development machine and the robot, the Pi Wi-Fi on the Pi. Like one end of the room, it's okay. The other end of the room, it's just not good at all. But once I got my LiDAR running, I was visualizing it in RViz, and I would show it in RViz, but right now it's not working that good because of the Wi-Fi issues, I think. And I was noticing that in RViz, the LiDAR was being flaky. I mean, all the messages were coming out, but it would say basically go, I can't transform it. And so every once in a while I could transform it and stick out a message. And I made a change where where the transforms between all the links, like, well, I need to put that in the documentation, the ROS structure of the I guess of the different transforms, but from the LiDAR to the base link and to the map and to the ODOM and the map, I updated the transform rate on those, the broadcasters, to be the same rate as the LiDAR, and RViz seemed to work a lot better. And also, I was like the time of flight sensors, I was using 0 time, and everything was working better. until I made them real time, and then they started getting a little flaky too. And then when I changed the timing of the transforms, it ran a lot smoother. So I would have thought that the ROS running on the Linux workstation, like is a relatively good notebook, would have enough CPU power to do the transforms, but something's going on, and I don't understand. When I add time to it, I'm thinking of going back to everything and turning off time and just setting it all to 0, so it doesn't do a time transform and just does a spatial transform.
Well, are you familiar with sorry, with ROS with static transforms publishing on TF Static?
I was thinking of doing TF Static. I've had some minor issues with that before, where like if you start up RViz after you've done that static transform publish, it doesn't seem to find it. You have to restart it or something. But
that's how you're supposed to do things like LiDAR to baselink transform.
Right.
Things that don't move is you're supposed to make it a static transform.
Yeah, I was thinking of going back to static for those. Because that's the that seems like the proper way to do it. But and maybe that would take some of the time stuff out. So it's easier to do a time transfer.
Right.
Because I guess it's a lot of calculation to figure out, oh, this one occurred at this point in time, and this one occurred at that, and it has to figure out.
Interpolate between the data points that it has for the different links.
Right. Yeah. And I guess the data points themselves have their own timestamps, and the links might have their own timestamps. So I'm not sure. Yeah, there's some stuff I don't know about transforms, like the timestamping. Last year I turned everything to 0 because 0 timestamp, because I just couldn't get it to work. It was fighting everything. So it took hours just trying to fight my way out of that paper bag of timing, the timestamps. But hopefully I can get something a little better, and I'm going to try that static transforms and see what happens. I might have to just push them periodically too, just to keep them fresh instead of just once at startup.
Cool.
But, yeah. So I'm just glad that the sensors are working. They line up pretty good on the RViz. Like all 3 or 4 of the sensors pretty much are stacked on top of each other on RViz. When you see the dots, they're really close to each other. Yeah, because if I put like an object right in front, then the point sensor that just points forward can see it, and then the 2 side sensors can see the same point, and those both line up because I have calibrated it so that when it sees something, I just made sure that what it sees, everything was transformed to the same location in the XY map, and then the LiDAR would see the same thing and transform, and it would show up in the same spot on RViz. So I'm pretty pleased with the sensors. Yeah, that's my update right now. Wish I could get a gold star, but
So do your wheels spin? Do your motors spin yet?
oh yeah, well, teleop, yeah.
Okay. Oh, okay.
Yeah, so I can drive it around and see the map change and try to find a can by just doing instrument driving and
Cool.
and grab it. And then got to figure out how to do the navigation stack. Yeah.
All right. Well, thanks, Mike.
All right, thanks.
Any other
That's
questions?
really
for
cool,
Mike?
Mike.
If not, I've got a perfect springboard off of Mike's presentation. Okay, so let me present. Let's see. I think you want to pin my cell phone. I should be sending on my cell phone. Are you all seeing like the cell phone image of the robot?
It's a black screen.
Okay.
Yeah.
Oh, I got to present it. Just mute this.
You got the mic enabled on both of them now.
Yeah. Always challenging to get all of this working. Okay, let's try that. And then turn this off. And see if that works any better.
Just a black screen.
And then if I share my window, how do I do that? Share screen.
Are you sharing the screen of the phone? Oh, I see something.
There we go.
Something changed. Yeah.
Yeah. Let's see.
Yeah. It looks like you can see the whole phone now. Yeah.
I think. Camera.
I see it now in the smaller window. Yeah.
Oh yeah. Okay, good. So, first demo.
You got an echo going again.
Yeah, let me see if I can mute this. There we go. Mute. And is that better? Still got a bit of an echo, don't I?
They're both still on. You want to not mute the phone, but mute the PC camera.
Yeah. Looks like the camera.
Otherwise, it won't show up in the recording.
Okay. Okay. How about that? That sounds better.
No, you got to do it the other way around.
Oh.
You want to unmute the phone so it can show up in the recording, and then just mute your PC.
Okay. So like that.
That's better.
Okay. So I modified the Lino robot stack to
Your PC's back on again. Oh, there it goes.
To accept a command onto the servo, and so if it issue a publish command, so there's the can grabber operating, and
your grabber's fancier than mine.
there we go. So
is it a can grabber or a can crusher?
well, good question. It's really only a grabber. Wrong way.
Hold my beer.
Here we go.
Maybe a grabber. There.
Oh, there we go.
Like a rat trap. It didn't crush it though.
It's tight.
Yeah.
Yeah, my servos seem to buzz when I grab too hard.
Yes, that's what I was going to say. You should have it so that it just touches you need to adjust the angle that it closes at, because if you don't, your servos are constantly trying to get there, and they'll overheat.
Yeah.
I noticed on my battery sensor, I was drawing an extra 300 milliamps when I had both servos buzzing.
Yeah, you don't want to do that.
Right.
They have to reach gold.
Okay. And then the other thing that I wanted to share is just bring it up and let me put the robot out here. So you got the hallway set up, and okay, I'm going to, hopefully this will come up, and come on baby, come to life. Okay, and I'm going to share this window. Obvious. And you should be seeing the obvious window, and I'll set, you got to give this thing an initial pose estimate. And you can reposition it as you see the need to. And
So, looks like it's been wandering all over the house, not just the hallway.
These are like various points that it picked up when it did a SLAM, when it mapped the hallway using SLAM.
Huh.
And so now you guys are seeing the Avi's window, right?
Mm-hmm.
So now I'll do waypoint nav through poses and set a pose, nav to goal down here, pointing in back up the hallway in the opposite direction to which it'll come from, and then set a second pose back where it is now, pointing towards where it should go, and then set it to do 2 loops. And if I'm really lucky, this will work. Start waypoint following. And you guys are seeing the robot in the hallway, right?
I see it on RViz, but not on your phone or anything.
Your phone looks frozen.
Oh, really?
Yeah, it's showing your keyboard still. Now we see it.
There.
Okay. Must have been slow to catch up. Okay, so you're seeing the robot doing a turn now?
Yep.
And if you look at RViz, you'll see where it is in the map.
Mhm.
And so I set up the can so it has, and you'll see that the path kind of wanders around. I'm just going to stand here, and it should modify the path. The local planner should modify the path to avoid my feet, which it does. You can see it's going around me.
Thought we were going to see a toe crusher.
And it's doing its little back up and turn movement. And you'll see if you look at RViz, you'll see it detect the obstacles. It's not to a point where it's detected the far set of cans yet, but it's getting there. And you'll see the path on RViz change as it figures out a new route. And now
So now, what would happen if you made it go like twice as fast?
What's that?
Can you make it go faster?
Okay, I'm just moving the cans to give it an obstacle. Now it's replanned around a new can location. I've got the speed turned down because I thought that was maybe causing me grief, but it wasn't. So it should go faster, but I just haven't gotten around to trying it.
Now, the reason I'm asking, because last time when I haven't used it on the ROS 2, but on the ROS 1 with the nav stack, I've always found that it really, I wasn't able to make it go fast. And I don't mean like really fast, but I wasn't able to make it go faster than that. It was really
Okay.
like, and I found it always wanted lots of free space, right? I couldn't tweak it so that it was okay with more narrow passages. Those sort of things.
So I can see how narrow I can make its passages. It does pretty good. It'll come within, a couple of inches of. Oh, that's too close. It thinks it's detected a collision now, and it's trying to recover.
Yeah, isn't there a minimum distance for the LiDAR? Like maybe 50 millimeters or so, maybe longer? I wonder if it's running into that as a limitation. If you get things too close, you just can't see it.
No, the LiDAR will detect stuff that's right up there. It seems to have gotten stuck. So,
Claustrophobia. That's what it is.
It's pouting.
Yeah. So
What
thanks for the
happened to your
suggestion
map?
for the demo, Chris.
All you got to do is kick it.
Let's see if there's an error message that makes sense. No. Cancel the goal. Cancel the goal because it figured it couldn't get through there. Oh, I see what happened. Okay, so at some point it lost localization. So let me see. I'm going to stop the video. I'm going to disconnect on the phone now.
Yeah, we can't hear you if you're saying something, Paul.
You're still on mute.
We can all hum. Do, 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 do.
Can you hear me now?
Yes.
Yeah.
Uh, Can you hear me now?
Yes, I
Yes,
can hear
we can
you.
hear you.
Okay. I think I'm back now.
Hmm.
So sometimes it does this. Can you see my cursor on the RViz window?
Yeah.
So you see where there's this line across the hallway. At some point, it lost localization, and I've noticed that happen now and then, and I haven't figured out why it happens, but the map frame, the odometry frame got turned around, rotated relative to the map frame. So now it thinks the LiDAR is the things that the LiDAR is picking up look like obstacles placed across the hallway, and it shows that the robot is pointing about downwards and to the left.
Is this what Chris was talking about? If it goes quote too fast?
I think this is what Chris is talking about, and it's actually pointing downwards and to the right. So I can reset the pose estimate, and hopefully that will all come back to what it should be. I'm trying to tell, from the LiDAR image when you got it lined up right. There we go. So that should be enough to let it continue. But maybe it's too far gone. We'll cancel accumulation and set a nav2 goal. It's not far from it. There we go. So now it's recovered, and yeah, look at that. That's exactly the problem. And I don't know why it does that. I know one of the things that was causing it was I get dropouts on the Wi-Fi between the ESP32 and my laptop.
Yeah. Paul's doing the actual raw heavy lifting on the laptop and not on the robot.
So it's actually pointed up in this direction, best I can tell.
How good is your time synchronization between laptop and the robot, Paul?
That's a good question, Chris.
Mike, you were, before recording started, Mike, and I had to step away for 10, 15 minutes. You were talking about some issues with your LiDAR and RViz, and I was going to say, I mean, I've run into issues before when I have things going on the robot, let's say on the Pi, and other stuff going on the laptop, including and especially RViz. And if those were not perfectly time synchronized, things just were not happy.
Yeah.
Interesting.
Yeah. And
Because then I used to get messages like, oh, you can't interpolate into the future and this and that. I mean, you had to really be spot on with your time synchronization.
Yeah, I was getting those even on the robot itself and not going between two different operating
Okay.
systems.
Hmm.
But that was last year. This year, it's given those issues on RViz. Yeah, but last year I was trying to do transforms on the robot between stuff, and it would give me those things. I can't do it. I can't do it. And that's when I said, okay, I'm going to not timestamp anything, and then things started working. So it's okay. Everything's 0 time. But I want to try to do it right this year with timestamps. Yeah. So last year I cheated. So, but I wasn't using the navigation stack. I was sort of just making my own up. But mine had similar issues with the losing localization, even with my own code.
Yeah.
That's why I didn't win last year. All three of my chances at lost localization went, oh. And then before and after the competition, it kept localization.
Yeah. And it's like, and you can see it like trying to fix its localization, and then it'll get messed up again. So I mean, you're asking really good questions, Chris, and I just don't know. Haven't played with enough, but
Yeah, that's the thing with RAWs, right? How do you troubleshoot this sort of problem, right? It's such a big black box, and you don't really know what's going on inside, and it's like, yeah, how do you troubleshoot this? I don't know.
well, I actually found a way to troubleshoot it for one of the causes, because what was happening, the Lino robot software on the microcontroller pings the agent on the laptop, and if it missed one ping, it would reset the microcontroller software and restart all the publishers and subscribers. And if the robot, and this was happening every like minute or two, so if the robot was moving at the time, and particularly if it was rotating, then suddenly there was a dropout in data coming from on the / odometry topic, and also on the IMU topic, and the extended Kalman filter would just go crazy and produce nutty stuff on the filtered, what's supposed to be the EKF filtered ODOM topic. Particularly the orientation would go all wonky, and that would cause the transform between map and base link to be all wonky for its rotation, and that caused the LiDAR to go all out of whack. And so I found that by recording a bag file and graphing the orientation Z and W quaternion terms, and you could see it do a jump. And on Ross bag, you could see coincident with that, you could see time, see it stop publishing ODOM. So that told me, hey, ODOM is going through jumps, and that's causing the map to base link transform to go all wonky. So I'm confident. So I fixed that by making it more tolerant of lost pings. But I'm not seeing lost pings now, but still occasionally seeing this wonkiness like you just saw. So I don't know what causes that, and still more work to be done.
Yeah, we know what can be done because my Roomba works pretty good.
Yeah, right. My Z-Rock Q5 works real good. So yeah, I know it can be done, but it's haven't had enough time to tune it up. So anyway, when the talk on Saturday is not like really about, well, here's a finished rock solid thing. It's about, these are the nav2 concepts involved, and the Lino robot 2 architecture, and how you configure it, and so you can do this with actually zero programming, because other than the bug fixes that I put in, there was no actual programming needed to do what I just demonstrated. I have been given committer access to Thomas Chu's Lino robot repo, and I've put in a few fixes for things that were broken. So anyway, I reckon Lino robot is pretty good stuff. And so anyway, that's what I had to show.
You're doing pretty good. Yeah. Anybody can get it to run on, well, not anybody, but you can always get it to run on simulation, but on real life, it's a lot harder.
Yeah. So Chris, I understood you to say that you found time, and Mike, you guys found time synchronization to be a major issue causing this kind of effect.
I'm not sure if it was necessarily causing this. I think I have seen this effect also. I don't remember if it was linked to time sync, but what I was trying to say is, in general, with two computers on a network, I found that time synchronization was critical for RViz to be happy. Now, again, you might have another issue going on, or multiple issues going on at the same time. But for sure, time synchronization is the first thing I would check and read up on, how important it is. And how to, I had to, somewhere I've read that you really had to, the one recommendation I found was to turn one of the two computers, into the time server, and the other one would just grab it, using NTP or one of those protocols. So
yeah, so ROS uses the computer time. It doesn't have its own time, I guess, or it uses it as its sync. So if you fix the computer time, then the ROS time,
right, exactly. So you can use things like NTP and variants of that to keep the two computers synchronized.
Yeah, and there's a level of unknown here because it's running microROS down on the ESP32, and I don't know where it gets its notion of time, or how that synchronization with the computer time is done.
It's a good point. That microROS, that publishes information, right?
Yeah.
And that would be time-stamped. You have a good question. Where does it get its time from?
Isn't microROS used typically as a peripheral to, quote, big ROS?
Yeah, and that's exactly what's going on here. So the code for what's running on the ESP32 is actually pretty simple. It just waits for, and it looks like a ROS subscriber and publishers. So it sets up subscribers and publishers at the outset, and then periodically it polls for an update from the IMU and odometry, and when it gets a command vel motion message, it posts that somewhere that the that the motion controller can pick it up and send it off to the motors. So,
Where's your EKF running?
What was that thing?
Where is your EKF running?
On the laptop?
Oh.
Yeah, the topics. Let's see. Okay, so the topics emitted by the let's see.
Yeah. Yes, I did a search and there's something that you can synchronize micro ROS to ROS with a command.
I mean, ROS also publishes time. It's time, I think. So maybe that's where micro ROS picks it up from. But I'm pretty sure ROS has its own notion of a time topic that it can publish.
So anyway, more work to be done. But you got me worried now, Mike, because it could your effect from last year could easily happen to me, where it mostly seemed to like keep localization, but it might fail 3 times in a row.
Yeah, it's going to start happening on Friday night.
Yeah. I was going, it's not going to fail 3 times in a row. I'll win one of them, but nope. It seemed to only fail 1 out of 3 or something at home.
Okay, I think if there's no more discussion on that, Fernando was up next.
Hello. I was wondering if I could present on 2 different things.
Yeah.
All right. So let me fix my camera.
I loved your video of testing the swerve drive, Fernando. That was really awesome.
Thank you. So about swerve. So we built a new chassis for it. Now we have 2 pods instead of the single one that we were testing last time. So they're next to each other, parallel. Omni wheels still for supporting the edges with no swerve. And here's the top. The chassis is actually 3D printed. It split it up into 4 separate parts and then just connected it together with all the with the pods and the things holding the Omni wheels, as well as these supporting extrusions in the back. And then we haven't been able to test anything yet, unfortunately, since we still have to get code up and running. We're hoping to first use basic code like what we used for the single pod swerve, and then kind of upgrade based on Roadrunner motion planning library for FEC that's primarily using FEC. And change it so that we can use a variable amount of swerve pods, because we'll have to use 3 for a robot that we've been trying to build for a while now. So we've been going from 1 pod to 2 pods and just getting our documentation done and seeing how each different configuration works.
Wow.
That's really neat.
And then for future plans for the swerve, the pods, I think I'd say they work decently well as they are, but we do need to add extra tensioners here for the belt, since the steering is belt driven. So we need to add a way to make sure that it's more fixed, because these can still slip a little bit, especially after a lot of driving. And then here on the bottom, we have no actual way of indexing where the pods are. So if there's some kind of slippage, we won't. We're tracking the rotation, the steering, but we won't actually know if there's slippage. So we're planning on doing some kind of sensor, probably like a touch sensor, or I think that's what they called. What's used on typical 3D printer, like an Ender, the switches at the ends, where its limits
Limit
are.
switch. Yeah.
Limit switch, that's the word. Something like that to know when their pods hit a certain direction, so we know that it's at X position in case there was some kind of slipping. I think those are the main upgrades we're looking into doing for the swerves right now.
So, what do you have position feedback of any kind on the swerve swerve angle?
Steering.
The steering, yes.
Yes.
So here is a through-bore encoder. So how it works is the whole pod turns, and that turning is controlled by this servo, and yeah, you can see it on this one. There's the pulley's connected directly to the servo, and there's this axle that connects to the pulley. So whenever this turns, you can see that the axle and the encoder turn.
Oh, I see. And then, do you have encoders on the wheels to know how far what their position is?
Yeah, they're built into the motors. Here's the port for that.
Okay. Oh.
So what kind of slippage were you referring to before? Was it the swerve wheel on the surface, or?
No, that had pretty good traction. It was the chassis. We had no control over the rotation of the chassis since it was just one pod, and then so the Omni wheels on there were the ones determining that, but it was random, and then they would sometimes slip or skip because how they were mounted was pretty inefficient, and the extrusion that they were mounted on would have contact with the ground, and that would cause issues with the driving.
Oh, okay.
Oh, sorry. Sorry, did you mean slippage as in what I meant for the actual drive belts for the steering?
Yeah, I wasn't certain what kind of slippage you were talking about. So your belts are actually slipping, like skipping teeth?
So we're just being cautionary for that. It hasn't happened yet, but it is the possibility that this whole unit here, which has the servo and the steering components, can move forward in case or the belt loses tension. So we want to add a better way of tensioning instead of just doing compression with screws and
friction.
nylock nuts.
Yeah.
Friction.
In the middle of the match, if you if you skip a little bit on the steering on just one of the modules and you can't detect it, you're in trouble because now they're fighting against each other because they need to. Their angles need to work well together for the actual motion of the robot you're seeking. So there needs to be another way to detect it. So those encoders, while they have an index on them, it's on the side.
It's on the servo.
It's on the drive side of the pulley,
Yeah.
and it won't detect it if it skips. So there needs to be something to be able to double check or run an index or calibration or something like that on the actual direction that the pod is pointing. And we were thinking about all sorts of different things. So if you guys have any ideas, that's great. We were thinking about limit switches hitting protrusion. We were thinking about optical sensing, like reflecting from a mirror as something goes past infrared reflection sensor, that kind of thing, or something to detect the width of. You could have a printed disc on the bottom there, either the bottom or the top, that has a line that gets thicker as it goes around, and so you could have an absolute, like from an analog input, how strong the signal is. You could have an absolute encoder on the turning of the steering. And then it would have a step function to like get near all of a sudden, and so you'd know it that way.
Are you thinking that just a periodic sensing would work instead of continuous?
Yeah, I think we can rely on the high resolution encoders on the bottom to do the continuous, and then this is just like a double check. If something seems wrong, then driver could trigger a calibration routine to double check where the belt actually is.
Yeah, here's an off the wall idea.
Those are the kinds we like.
Okay, well, I'm just wondering if you mentioned that if they get off, they start fighting each other. I assume that shows up as higher current. So could you do
Yeah.
a current monitor and use that some way to tell you when you, otherwise if it's an acceptable limit, you're good. And if it suddenly starts to rise, you've got something wrong, and then you could trip your routine to go ahead and do an absolute. You know, if you're just trying to get it to one absolute position, that's easier than continuously monitoring. I don't know how you're calibrating. What I'm just saying is you might be able to use the fact that when you're out, you have a higher current. Just throw
I think
that
that
out.
would only be like, you have to worry about what threshold that becomes a detectable thing. And I think it would only show up once they're significantly out of tune with each other, because they're always fluctuating anyhow, because you got differing loads as speeds and intended direction changes and things like that. So it would be hard to sort of profile what is normal and what is abnormal unless they're like pointing significantly away from each other.
Okay.
What could
Can you
you
add a belt tensioner to the belt?
Yeah, he's doing that. That's one of the things he talked about.
And then I guess the other idea is just a wider belt.
Yeah, or one with bigger teeth.
What kind of encoder do you have on this servo on the drive side? What type of encoder is that?
That's a high dollar rev encoder, I think, right?
Yep. Rev through-bore encoder. Any more specifics on that? And I can't be any help. Not really software side, unfortunately.
It's like 4,000 counts per revolution.
Yeah.
Quadrature encoder.
Yeah.
Yeah.
And it has an index on it, but that index this is one of those situations where the index is not compatible with the FTC control system, but it is with the FRC control system.
Okay, could you
Although there is a way with a third-party peripheral to get access to the indexing. So it's not impossible, but you gotta get more electronics.
could you somehow couple another encoder, quadrature encoder onto the wheels, so onto the rotation of the wheel, not the rotation, but the angle of the wheels. Because you have a speed encoder, of course, on the motors.
Yeah, that's what I was saying. Like if you tip it forward a little bit, Fernando, and then back up a little bit, because I want to see the top wheel of the. Yeah, see the top. No, the top wheel of the. Sorry, the top disc. You're holding it a little too low. There you go, right there. Right. So yeah, that guy. Right there is a good surface where you could put a printed encoder disk, possibly. And that's the one I was talking about. If it had a line that got thicker as it got round and then diminished to zero.
But if it was just a nice slotted encoder, you could.
Yeah, but then you have to be able to go through and reflect and all of that kind of stuff. So I was thinking a simple analog reflective sensor might be good enough for that.
Well, a couple other ideas. You could use some of these really tiny neo magnets in
like a Hall effect.
Yeah. Otherwise, you can buy these things that are like pencil lead thick.
Yeah.
I mean, they're really small.
You could put, say 8 of them spaced around that disc, and then have a sensor that detects.
Yeah, and another thing you could
that's
do,
pretty crude, though.
Another possibility is you could use like a limit switch. So, a lever switch with a ball on the end of it, and you could have some bumps, so that as it went around, it would go over a bump. So I don't know if bump's not the right word, but it is a bump, but more like say if your top disk had a star pattern on it of lines, like a snowflake, just or an astronaut. What's the thing that has you know, on a computer, it's a star where it's an X with a cross in it, something like that. And so that when your limit switch went around, it would bump up, close, and then when it dropped down on the other side, it wouldn't. I'm just looking at some possible
Like
ideas.
teeth on a sprocket, maybe. A chain sprocket.
I have another idea. That's use a flow detector, like a mouse, to look at that disk and you'll see the movement of it as it spins. But I guess
Optical flow?
That's a relative. It's not absolute, so that wouldn't work. Right. Never mind. Scratch.
You've got to have some kind of absolute indexing, and
Right.
you don't have that right at this moment, right?
Well, then you have gray code. You could use a gray code encoder.
Yeah. But that you in some way you got to be able to initially align them when the robot powers on.
Yeah. But so I could think maybe either the magnet idea, and you could have a second magnet, so you could pick up a second Hall effector. Otherwise, it would be an absolute zero. Or you could use a gray code. You
But
know, that could be reflective.
What about
Paper disc?
what about the dumb and simple approach of putting a mechanical stop, and then you just run the motors at low energy until they must have reached the mechanical stop, and then they must be aligned.
Yeah. That's
Well,
sort of
the
like, that's sort of
goal
like
is to be able to.
Go ahead.
The design here is probably overkill, but overkill's fun, and it's that they can turn endlessly, right?
Mhm.
Because if you're following certain curves, right, then you technically only have to be able to turn 90 degrees, and you can get all of the different motions that you want, but then it becomes discontinuous. Right.
Yeah.
If you're doing a gradual turn that keeps going round and round and round and round and round, right, then the closest approximation is always just a teeny bit more. And then if you want it to be able to keep going round and round.
Yeah.
Well, you're going to wind your wires up, though, aren't you?
No, there's no wires there.
They go to the top of the motor?
The motor doesn't spin. The top motor doesn't spin relative to the frame. It's just the steering that spins, and that's being driven by that belt off center.
Yeah, there's some gearing. Yeah.
And there's no wires that have to go through there.
Yeah.
Well, I like your idea of the top plate. I think that sounds like a right thing. But I think with a nice flat disc like that, you could do a lot of different types of encoders.
Mm-hmm.
Yeah, we just need a recommendation of which direction to go. It's most likely to be successful fast
Optical.
and cheap.
Optical.
I think, I would think you would, just like a line of those cheap IR sensor detector pairs, and you just do a gray code. Then you have absolute, you know exactly where it is.
How wide is that drive belt? Is it like a half an inch? Or wider?
I think 9 millimeter. That's probably 9 millimeter.
Oh, okay. Yeah.
Yeah, you can go up to 15 millimeters probably.
God, I'd be surprised if that thing would skip.
Well, the truth is that it probably won't, because it hasn't yet when it's tensioned properly. Now, you never know what happens in competition, but the bigger concern is that then what are you doing to align them in the first place?
Yeah.
You're eyeballing it, right? You got to turn the robot over and sort of line them up, and then power up and say, "Oh, that all looks good."
Yeah.
You probably
you can make
need
a
to
jig
align
to
this
stick
thing,
your
right?
wheels in,
A jig, yeah, that's true.
Yeah, to hold the wheels in a certain position and then say, okay, that's 0,
Yeah, but I think Paul's idea of just a single spot where if you only need to know one position to get
Yeah.
calibrated, then you just, all you need is one single spot.
That's right.
But if you want to know if you've lost it, then you need some sort of encoder.
You need the initial positioning, which could even be as dumb as you power it on and you slip it into a jig and it aligns it, and then you lock it there. But what you want to be careful of is not to have conflicting sources of information that can conflict with each other, because then you end up with a mess, because if they disagree, you don't know who's right. And then you start stepping towards the voting kind of scheme where 2 out of 3 computers or sensors have to agree before it accepts the answer, and it just keeps getting complicated. But two sensors doesn't help you. If they disagree, it doesn't help you determine what's true, because either one could be wrong.
Yeah, that's why an absolute encoder would be a decent thing to help. And the whole jig idea is fun, but we've been known to have power interruptions and things like that as well. So it's like, it's not necessarily and you can't like go into the field to retrieve your robot once the match is started.
Yeah.
Very cool, though. What completely different subject. What do you envision it being like to drive? Like, do you envision that the operators would have a rotation control, which means they could spin it to some orientation, and then a forwards, back, sideways sort of holonomic slew control? Or what's the driving model that you envision?
I personally didn't think it that far through. I had completely forgotten that chassis could spin until I thought of the 2-wheel, since I'd been working with the 1-wheel for a while. But they'd probably have to be separate controls for the drive and the turning. Because the whole point is you don't turn the chassis. That way there's less, I guess, time wasted on it. And then I believe they might also give you more traction, but I'm not sure about that one.
On their other holonomic platforms, that's what they do, is they do field-oriented controls. So that the driver's controls, you use X and Y on one joystick to do translation, and it doesn't matter which orientation the robot's turned in, it will translate in the real world according to the driver's standard alignment to the field. And then on the right joystick, left and right, governs the orientation of the chassis.
Okay.
Well, in cars that have 4-wheel steer, apparently they use like there's a threshold speed that in like low speed they'll turn opposite of each other, and high speed they actually turn like with each other or parallel. So I wonder if that's kind of synonymous with 2 swerves.
Don't have to do that in this case. There's no reason to change up the mixing model.
Yeah.
It's just a matter of how fast you want to go, is how far the sticks are deflected.
And then another question: why do you use omni idlers as opposed to a caster?
Ease of access, I guess.
What?
Ease of access. I mean, we have
them.
Easy to implement.
We have them. They also don't induce any kind of torque on your steering like a caster can, right? When your caster is reversing all of a sudden, then they have to swing to the side a little bit, and they can induce something on the chassis.
Yeah. I was using a ball caster on mine this year.
The ball casters are nowhere near as efficient as the Omni wheel casters.
Okay.
The friction is always higher on the ball casters, and their likelihood of getting gummed up with dirt and debris is much higher too.
Thank you.
Yeah. So this slippage thing, is it one of the concerns is during competition it slips and you need to know about it. I assume that's your biggest concern. I mean, the calibration pre-show is always a concern too, but the one that you're really thinking of is, okay, it's calibrated and then it slipped during the competition. So would you stop and do a calibration check every so often, or just want continuous monitoring?
I think the idea would be it just what's it called? It would continually hit the absolute limit switch or whatever we end up using, and that way we know, hey, we reached this position, so we're good, and continue, and it just continues to do it. I'm not entirely sure though.
Yeah. So basically, it's going to be moving and rotating a lot, so it'll hit it quite often, I guess is what you're saying.
I'm not sure that that's necessarily true, because it sort of depends on which paths you have to travel, because it will still always take the shortest, it should take the shortest turning in any given change of direction that you're trying to achieve. And so depending on the paths that you're doing, it's not necessarily going to trigger something that requires you to go all the way down around 360. If it was a gray code, then it would be triggering all the time.
Yeah. I was thinking you probably want at least 4 points that you want to know about.
Yeah, but it still has to be somewhat absolute. Or
right.
Yeah. And I would say it's it's pretty equal. The calibration, again, we can lose calibration if there's any kind of short interruption of power, or we get static shocks every once in a while and things like that. So the control system can be interrupted, and but drivers at least during the teleop period could trigger a calibration anytime they decide that something looks wonky.
Yeah, well, I was going back and forth between what I want to put magnets on there, which are really cool. They're neat, and you can use a Hall effect sensor, or do I want to put something reflective and use an optical sensor? It depends on, well, yeah. So I'm not sure which one I would use.
There's pros and cons both. Yeah.
Whichever one has the sharpest detection, I guess, the most reliable, and you know exactly where it's at when it happens. I think optical might be easier that way.
Especially if you're using an IMU.
Huh? We'll put an IMU on the wheel. No.
Got IMUs on the platform, but yeah, probably not on the wheel.
Yeah, you'd have to have wires then, or you could.
Then you got to have a slip ring. Yeah.
Yeah, or a ESP32 and use its wireless.
Wi-Fi. That's okay for summer projects, but it won't translate into competition seasons, since that's disallowed electronics.
Mm-hmm.
Did you have something else you were going to share, Fernando?
Yes. So this one's personal project. Last week I said I was under the assumption that I had bricked my Ender 3 when trying to upgrade it to Clipper. However, I think I was just not looking at things carefully enough, because it ended up being that instead of using the LCD screen, now you use the whole web interface, and the LCD screen just doesn't work unless you do some kind of extra install onto the printer firmware. So now I have it up and running again. And right now it's printing a helical gear for another project that I've been working on for robotics. But I still need to do some tuning. And then with the whole web interface, it's being run off of this Pi. And I can just control the printer from here. Speed, acceleration, velocity, pressure advance, extrusion factors, homing. So pretty much everything that was on the LCD control plus more is now being done from up here instead.
Nice.
Yeah.
Boy, that's a fancy Ender 3 setup you got there.
Yeah.
Yeah, I believe I was doing that with Octoprint. So
I think Octoprint allows you to also allows you to view the thing, which might need which Clipper might need something else. So Octoprint does have that benefit where you can monitor it through a camera, and the thing's built in, right?
Yeah, and it can run Clipper, but yeah.
Mhm.
So I'm not sure what. I haven't done anything in Clipper in a long time, but because it just keeps working.
Mhm.
Cross my fingers.
That was it. Thank you all.
You're not
Well,
using like Protoneer or something on the Pi, Protoneer board.
Sorry.
That's the manufacturer. Protoneer.
No clue.
No clue. Okay.
No clue.
That's
The
great.
Pi is just running the web interface, right?
Yeah.
Oh,
Yeah,
okay.
it's just dedicated to that and running that monitor.
I bet you were relieved when you figured out it wasn't bricked after all.
Yeah.
Isn't that the most sickening feeling when you think you bricked something?
Yeah.
Cool.
All right. Thank you all.
Nice work, Fernando. Thank you. All right. With that, let's switch over to open mic.
Hey, Paul, I got something I want to show.
Yeah.
Part of open mic. I see here. All right. Ta-da. It did come in. I'm starting to populate the board.
Oh,
So far I haven't found any blurring errors, but we'll see how it goes. So it looks pretty nice. I think it's going to be really cool. We'll see how it goes. I'm hunting down. I bought on the web a lot of buck converters called Mini 360. I think that's it, Mini 360s. And I've got, buckets a load of them, but I can't find them. I don't know where I put them. So I think I even have 2 bucket loads of them, and I can't find them. So that's holding me back a little bit, but eventually I'll find them. So
they're like 4 pins that make connection.
yeah,
2
for
for in,
those,
2 for out.
yeah, for that one. And you can get them in fixed voltages, or you can get them variable. The
Right.
variable is the most common one, but I don't trust that little dinky
Open
carbon
air potentiometer.
whatever it is. But so I have actually desoldered that, and I know the values of the resistor that you have to put in, and so I just hardwire them. If I can't find the one that's already been made that way.
Yep.
It's pretty simple. It'd be even simpler if I had done it with what do you call them? Surface mount, but unfortunately the ones that I have the right values for, they're actually through hole, so I have to kind of like fudge them a little bit. But it's much more reliable than the little thing, because if that fails, essentially whatever's hooked up to it gets full voltage. I mean, it's not a pretty fail. So, when you're
What do you
buying-
mean? How does it get full voltage?
Well, the resistor you're adjusting is the feedback resistor for the regulator.
Oh, okay. I see what you're
So
saying.
if you open it up, the thing doesn't see the feedback, and so you've lost feedback. So it just goes to the wall, which
Whatever the input is. Yeah.
whatever the input is. So you don't want to do that.
Yep.
Hey, can you hold that board up again so we can have a good
Yeah,
look at the board?
I put in the driver, the motor driver in the ESP32 module, but I'm not, I haven't done my preliminary tests yet, so I just put them in there so it wouldn't be a completely blank board.
Okay.
So over here you see on this side right here, these are the 2 motor connectors. That's the battery connector. Down here is the encoder ports.
Mhm.
Then these, if you looked at the board, I don't know if you can see it.
Yeah.
It's got really nice.
You're way too close for the focus on the camera.
Yeah, that's what
We'll probably see it better if you pulled it back a bit more.
Well, what I was going to say,
Well,
the silk screen has got everything labeled, so it's pretty nicely done. Though you always learn something. So we'll see how it goes, and we'll see.
Yeah.
Saturday, I might ask for a couple of volunteers and give out a couple. So if you're willing to buy the parts or I don't know, we'll see how it goes. I might have some of them. Well, we'll see what we can put together.
Oh yeah, I put Robbie's head back together and tested its camera. What kind of face recognition are we going to use to feedback from? I guess that's what you want to use a camera for.
Well, I think for the camera, I was thinking actually that we could maybe borrow on Tom's knowledge and go ahead and use an ESP32 cam instead of that little USB camera. Because all we need is 1 or 2 frames per second. We could, I think it doesn't have a pi in it. So there's no, the USB camera went to a laptop. So, you could probably manage to get, at least 15 frames per second. So I don't know, either solution would be fine.
I figure we're going to be using a laptop to control its movements.
Yeah.
Right.
Yes. And what I was thinking is, Mike, what they did before is they used an OpenCV face recognition program. And so the idea was, you see the face, and it would send the coordinates. Right now, so the main one they wanted to do is have the head. So it would tilt to the right to center the face target and do this to face it so that they could follow. If somebody came into view, the head would move to go look at them. That was the intent. Secondary goal was to be able to have the arm pose point at the person. Like, hey, you stand back or something like that. I mean,
At least some kind of movement.
Yeah. But the interface is really simple. I mean, you just send it if I remember right, all you send it is an XY, I believe. And I don't know. I'd have to look at the code. But for the face, we had that working at one time. It would actually look at you.
Mm-hmm.
So.
Yeah. So I think if you just put the camera in however it fits, and like Doug says, we'll get the location of the face off of OpenCV or whatever face recognition thing we use, and then drive the motors to drive the pan and tilt on the head to bring the face into the center of the image.
So is it going to be like a Python code running on a PC, or?
Python was what was there originally. Yeah.
Yeah, I think it was OpenCV, and most people find Python easier on OpenCV than writing it in code. You can do it in C; it's not a problem, but Python is easier.
So Python would work within the OpenCV environment, so you wouldn't have to connect between the two.
OpenCV they have a Python library.
Yeah, and you can write some support code in it. Yeah. Okay.
Right. Or, and I mean, you could, you
Yeah.
could even nowadays, you could, like I say, you could run a neural network.
Right. Yeah. I'm just trying to say for this Robie thing, it's like, okay, you get somebody's face and it's right here, and then the Python in the OpenCV would create the command to move the head.
Mm-hmm.
Okay.
Yeah.
Send it via a serial command down to the Arduino.
Yeah, it would send it to it, and then the Arduino would move it, start moving.
Right.
So cool. So you got the head put back together again?
Yeah. I mean, every single joint was, I would say, I don't have to do them all, and then I'd be putting it together and put some pressure on it, and then another joint would break. So I think I got all the joints now redone.
Yeah. Well, you have to take one panel off so to
Right.
get in there. So
that's what that Velcro is for. Yeah.
got it.
I didn't screw it all together, or I didn't hot glue all the panels on.
Yeah.
Well, my wife agreed to paint, to repaint the quarter rounds, which look a bit grubby on Robie's torso.
Oh, the
And,
head's me too. Yeah.
And if I get the head back, I could get her to do that too. She's
Yeah.
real good at painting.
I'm
And,
gonna try to make it this Saturday, so.
I thought you were
Yeah.
going to leave him a little abused to give him that, Star Wars look versus
Oh,
Star Trek, right?
I'm not worried about that. We can abuse it.
and then I picked up some of that white corrugated plastic from Doug, and so I'll make a back for him, and I got some more quarter round to, and then Holly will paint the shoulder. He's got that one unpainted shoulder. His left shoulder's unpainted.
Yeah, and I got to bring those shoulder circles and stuff.
Yeah. We got to figure
See how they
a way to Velcro them on or something.
Yeah, and they might be better to redo. You might find that you can make them fit better. Didn't Mark say he fixed the hand? Do you remember?
He was working on it. I don't know if he actually fixed it.
Okay. Yeah.
I thought he reprinted it in gray, though, right? Didn't he?
Oh, he's trying to get white.
Yeah.
Yeah, it's just the plastic he had, and he wanted to get white plastic. Yeah.
Yeah.
So, well, on my documentation for my robot, I'm using KiCad as my schematic capture tool. So
I wondered. I saw those schematics, and I wondered if it was KiCad.
So what should I use? Oh, I'll just use KiCad since it's installed. Yeah.
Yeah, that was a great course you did last month, Doug.
I hope you guys enjoyed it.
I did. Sure.
And the intent is to get people over that little initial hump that, when you get a new program, everybody says, oh, this should be easy. But, it's always hard to get started. But once you get started, it's not so hard, So.
Yeah, I had to make a lot of custom symbols.
Yeah. Yeah.
But they were pretty easy. So.
Yeah.
I didn't have to worry about footprints, so I was just doing schematics.
Yeah.
Footprints are the hard part.
Yes, they are. But it seems to be it seems like they could just do it's not like graphic programs are hard. I mean, not available. I mean, obviously there's Inkscape. You just think that they would have just stole a few ideas and incorporated it to make the graphics part a little easier than the way they did it. But there's probably some underlying reason why they can't. So, but you can do board outlines very easily in Inkscape. In fact, I prefer it. So, yeah.
All right. What else has anyone come across?
Well, Pat should put out the newest. There's a Kickstarter going on for
OpenMV.
OpenMV. Yes. So,
Oh, wow.
and it's kind of interesting. They have two cameras. They have one that's like their traditional camera, but like the next generation. And then they have a little 1-inch cube type camera that, to be quite honest, kind of reminded me of a Maxicam. But I didn't go into great detail looking at the Kickstarter. I just, but when you finish, the bottom dollar is if you get the $50 camera, which is the little inch one, and you pay for US shipping, that's $70. That's if you have the early bird. And at least when Pat was doing it, there were plenty of them. I don't know if there are now, but I think that if you miss the early bird, it goes up another $20, I think. So.
One of the things I think I noticed with the offer was that the larger camera has more flexibility.
Oh yeah, I mean it's all those add-ons that they were talking about, like
Got the add-ons, but I think the programming, the SDK, is more like the traditional one.
Yeah.
And I wasn't sure if the small version, the 1-inch squared version, was more like something you would do with what do you call it?
You mean like what do they call that?
The SDK, not the typical IDE, but that SDK everybody was using for AI.
I don't know. I don't know.
The IDE? You mean?
No, not the IDE. I think the bigger camera is capable with the IDE. The smaller one was.
I think it has the IDE too.
Yeah, I kind of got the impression.
I think it did. I had it too.
Well, probably I'm mistaken. That
I think. I mean, like I say, I didn't dwell on it. I mean, I did look at it. So that's definitely if you're in the market for one of those, But the delivery is in November, so it's not like you're.
In the meantime,
you're not going to have it for this year.
Get one of those,
Yeah, you're not going to have it for this year.
A Max Cam.
Yeah. Yeah, I think I have. Ray's played with Maxcam more than I have, but in theory, it looked like they had a RoboFlow type website where you could actually train your own model. So I mean, I didn't actually train a model on it, but I did look at it, and that seems actually pretty easy. I don't know how you, Brady, what were your experience? You went a little further with it. Did you?
Yeah, you're actually able to take the photos with the Maxcam that you put into, to create the model. And yeah, the actual creation of the model is, done online, and it spits back the model to you, and you download it, and it seemed pretty easy. It looked like they had opened up. It was just YOLO version 5. I think they've got version 8 and I want to say version 11.
Yeah.
Now that you can choose from. Initially, it was just 5.
Mm-hmm.
But yeah, it seemed pretty easy, and for what I did, I probably should have varied my photos a lot more and taken a lot more pictures. It would have produced a better model, but for the way I trained it, it would find the cone when
it looks like what you put in.
Basically, yeah. So
yeah. Funny about that.
Well, it doesn't work so well.
Well, I guess one of the questions I had was, do you have to take the pictures from the Maxicam, or can you take any pictures and submit them?
As far as I know, you can import into it and combine them. So it's not like you have to, if you don't take enough pictures, you can add to it. So, that's kind of nice. It's, it's not limiting to, okay.
Are they charging you for that service?
No, it's free.
Yeah, that's real nice.
Yep.
Because most of those things are starting to get a little bit pricey. They're not super, any one of them in themselves is not bad. It's just that if you're playing around and you start subscribing to everything, it gets pretty weird pretty quick.
Yeah. I actually haven't looked. Hopefully they haven't started charging for it. I might be surprised though. It's like, oh, it's charging for it now.
Yeah.
I'm locked in.
Yeah.
What I was thinking of was Edge Impulse.
Yeah, Edge Impulse is another one.
Mm-hmm.
So Edge, they're both compatible with Edge Impulse, and I believe the MicroPython IDE that OpenMV provides.
Well, that makes sense. Well, doesn't necessarily make sense, but I'm not surprised. Yeah, Edge Impulse, I'm really kind of itching to try that, but it doesn't support the OD type, the oak parts. At least I didn't see it on there. So RoboFlow, I think, is still easier than that for ODs. Anyway, yeah, I'm hoping to get this board and some code rolling, and with a little luck, maybe you might even have a frame. See how it goes. I'll bring whatever I have on Saturday.
Holler if you need a hand with anything, Doug.
Yeah, well,
but not before Saturday.
Not before Saturday. Just getting something together will be the trick.
Yep.
And I'm going to actually have to, if I want to use those yellow motors, I'm going to have to steal them off of some other robot. So, because I don't have an extra set of those just hanging around. And
here you can have mine.
I have one.
I don't think I could afford them, Pat. They got them shipped from Canada.
Hey, Paul, I wanted to ask you a question about your T. Well, I guess it's called a T Mini, I guess, on one of these websites. It looks like there is one that will tolerate greater light intensity. So I think the one I want to say is 60. The more expensive one is 60,000 lux, and the cheaper one is 30,000. And I wondered which one you had.
Who are you talking to, Paul? Ray?
To Paul.
Okay.
I don't have context, Ray. What
it looks like there were two versions of that. One was
two versions of what? A camera?
No, of your LiDAR.
Oh.
Yeah. The
okay.
One of them.
It's ambient light tolerance.
Yeah. One of them was like 30,000 lux. The other was 60,000.
Yeah.
Do you know which one you have?
I didn't think there were two. I didn't know there were two versions because I've just got the LD19.
Right. Yeah. Apparently, there's an LD19P, which stands for plus, and that goes for like $80, and the other one goes for 55 or so, 54.77 on AliExpress. But I wondered which one you had, if you knew. It looks like the plus is a lot newer than the.
Yeah, I think Paul has the old one because he said he had about $50 into it. Yeah.
Yeah, that might be it.
I want the RP LiDAR one. There's two versions. The one is a little more, like 150 or so. It's more expensive, and I believe it's got 90K lux.
Wow.
And then there's the one that's I want to say it's the A2, but I may be wrong. And I think it's 70K lux, if I remember right. But you'd have to look them up to be sure.
Yeah. Okay. Yeah, I was kind of curious. Other than what they.
Yeah, I
tolerate.
did look at, Bennywick. They're claiming they have one now that it's got a line, so it only reports one value. Okay, but the field of view is 14 vertical and 1 degree horizontal, I think. Now that seems strange to me. I would have thought it would have been 14 degrees horizontal and 1 degree vertical, but that's the way they reported it. So maybe you have to hold flip the sensor.
Rotate it.
Yeah. So, but they were claiming 4 meters at 90 degrees, 90. How did they? At 90 degree. 90K flux at 10% reflection.
Oh, reflectivity, yeah. Huh.
Yeah, so I mean that's really good spec.
Yeah.
And if they can do it, and so this is very similar to. So that's called their Luna. It's really funky because it's open back, so it's not protected in any way on the back. But the front is IP65. So I guess you can glue something on the back. I don't know. Anyway, it's kind of weird. But it's an alternative probably to the TF Mini Plus, which also has very good specs. But it's only got a 2x2 FOV. So anyway, it's just kind of.
Okay.
So Ray, I'm sharing the page for the item for the LD19 that I purchased, and this unit says 30,000 lux. So
Okay.
I guess it's the older one.
Yeah.
Yep.
Okay.
Yeah, isn't I don't know, didn't we determine at some point like bright sunlight is around 100?
It is here in Texas.
Yeah, 100K.
If you're talking July, you got 100K flux easy.
Mm.
But I'm not sure about in November. November's probably not quite that high.
Yeah.
Yeah, in Canada. Yeah.
Yeah. What is it in Canada? Can you see in November?
Oh, when the sun comes up in March.
Yeah. Yeah.
No.
Yeah, I don't.
not
That
nearly
was the
as
other
high.
thing that I remember. It's like I don't know. It didn't necessarily coincide with the month boundaries, but like December and January, you could literally go a month and the skies, you wouldn't see the sun. It would just, be hidden behind clouds for that long. So you can kind of see why people use those high intensity lights that, because they're not getting enough sunlight or something.
Hey, Pat,
Yeah.
I saw an email where you were starting to consider RoboRama. You had a room or something. Can you tell us a little bit about it?
Yeah, I'll let me see if I can pull up I shut down my other computer, but I'll pull that up. And
you got a
So did you make
flyer
a
and
course?
everything.
Stick it on the floor.
yeah, a flyer. Let me open another window. Documents.
You had to move all your wife's stuff out of that room because she did her own hobbies there. But now no.
She does quilting.
Well,
Not
gosh,
anymore though, right?
yeah,
I'm trying to get her to make me a robot cover.
she doesn't have a quilting machine, does she?
And no, she doesn't. She's got a sewing
Okay.
machine, but
Yeah, I have a friend who has a quilting machine, and the thing literally is like 10 feet by 10 feet.
Oh yeah, they can be huge.
Oh, wow.
so I put this together for them to post up at the at the site.
Yeah, yeah.
So RoboRama, May 24th. Events start around 2 p.m. upstairs at the Espanola Recreation Complex.
Yeah.
Contact me for more info. And then I just put some pictures I grabbed out of some of the videos, I believe.
Yeah, yeah.
So
Cool.
that's it. Just so I thought I'd put that up. They asked me to keep it 8.5 by 11, so that's what I did. And they're putting it up at the complex and at the local library.
Well, that's nice. So you got a room and everything.
I have a room. Yeah, it's about. I think it's approximately. I don't know, maybe 30 by 75 or a little smaller.
Well, that's big.
It's
Yeah, that's cool.
it's pretty big. It's got a bar in it as well.
It's got a what?
A bar.
Oh, okay. Well, that's always useful for, drowning your sorrows after
Yeah, that's right.
your robot
After the match.
had a failure or something. So,
So yeah, I just threw that together.
You decided to use Ross for the competition, right? No.
I'm having all sorts of stuff, but I'm digging through old emails about my Arducam time of flight camera, looking for distances, and I'm getting I'm not getting any values I'm expecting, and I said, okay, what the heck is going on? And I think I found my issue, but I'll know better by the next meeting.
yeah.
So
Have
I did
you
have
had
one,
any
the one we talked about last week, where I was having issues with the LiDAR and I wasn't getting values back as was expected. It turns out that there's a for loop for scans in LiDAR.interscan, and then a bunch of code. Well, it never ever breaks out of that for scans in LiDAR.interscan loop. It just sticks inside that loop forever. By the time it gets to the bottom, there's another scan ready. And it just, so it continuously spits out the values, ignoring absolutely everything else in the program. I got around it by writing a thread. So I start the LiDAR up in a thread, and I send it basically a tag saying, hey, just spit out one scan data for me. So the thread continuously runs in the background and monitors, and if it sees a bit, basically a value saying, hey, give me a scan, it'll spit out the scan, and when I receive the scan, I clear that bit.
Mhm.
And that was working, except that the LiDAR is throwing the LiDAR routine, the library, is throwing an exception once in a while. And it just craps everything out. And I'm not sure if it's a voltage issue on the Raspberry Pi.
Here, when I was playing around with rotating LiDARs, they were the older, the type like you had on a Nito. Yeah, it was actually an RP LiDAR, but it's their A10 model, and one of their early A10 models, not the one they finally ended up with. And I was running it on an Arduino Mega, and so in the default, the baud rate is 11,520, 155, 720, and I was literally overrunning the buffer, so I had to increase the buffer like 4x.
Yeah, I did that as well. So I was running into a limitation where the standard buffer, the default buffer in the routine is at 3,000, but I was getting back 4095 readings.
Yeah.
And so I increased the buffer size to 5,000.
That helped a lot, right?
Oh yeah, that resolved my issues with the buffer. but now I'm getting, it's like the LiDAR is losing, it's like when it screws up, you interrupt the scan, and it gives me, it throws the same error, but it's doing it sporadically. So it'll run for half an hour, it's fine. It'll run for 30 seconds and then it interrupts. And I think it's a voltage issue. And I'm using it with a little Sunfounder robot hat.
Yep.
And the reading up today, the 5-volt regulator is good for 3 amps. I'm running out of the Raspberry Pi 4B. So I'm wondering, am I getting a problem with the 5 volts and the Raspberry Pi that's causing a little bit of a voltage
This,
set?
I'll tell you what, you might run into a problem, because what really sucks up on the Raspberry Pi, what sucks the power, is if you've got peripheries hooked into the USB.
Yeah, so
USB.
I have nothing but the hard drive. I'm running a little USB to SATA hard drive adapter.
Okay.
And a solid state drive. And that's all I have plugged into the USB on the Raspberry Pi.
You shouldn't be pushing, it should, 3 amps should be fine, I would think. Are you getting low voltage readings?
I don't have a monitor hooked up, so I'm not sure.
Well,
So it's running headless on the Raspberry Pi.
you might want to just take a look at it.
Open
Open up the terminal and
errors.
you can follow
SSH into it. Yeah.
SSH into it and see if you've got a low voltage. That would tell you if you're popping the power, So anyway.
Yeah, it's the
Or didn't you get a new scope for Christmas?
I did. I just haven't hooked it up yet.
Oh, you gotta hook it up.
You gotta hook it up. You gotta hook it up.
It's still in the carrying case.
Oh,
Your wife's gonna think that, hey, that was a bust.
Take it out of the box.
What? I'll avoid the warranty if I take it out of the box. Yeah, I just haven't hooked it up yet. I haven't ran it, so
Yeah.
I'll maybe that's an idea, is just to monitor the voltage while this thing is working, because it just sporadically craps out, and it's doing it lately more often. It's really weird. So I put in a routine where before I started reading the LiDAR, I reset the LiDAR, because when you reboot the Raspberry Pi, it doesn't always kill the peripherals. So the LiDAR might stay running in an unknown state. So when I start up my routine, my script for Python, the first thing I do is send out after initializing the library, is to send out a reset to the LiDAR.
Well, another possibility is to temporarily power it with a Raspberry Pi 5 power supply, because when they pulled out the Raspberry Pi 5, they changed the type of regulators that they used in their power blocks, because they're now actually I can't think of all the names, but it's like a quick charge thing, and all they did was add a new mode to the quick charge, 5.1 volt at 5 amps. It's if I've been in the process of throwing away all of my Pi 4 power supplies and replacing them with the new 5 blocks, because we're just talking nights and days better.
Yeah, I am running one on here, a Raspberry Pi 4 or Raspberry Pi 5 power supply into the charging connector. It's the same board as used on the Pi Dog.
Okay.
It does have another disadvantage, is that when you issue a servo pulse out command on this board, even after power up, it's going to remember the setting that you put into it, and it just keeps sending it out. And that's just because it hasn't reset the board, because it keeps the board powered up.
Yeah, I actually used, I think it was a 3.2 3+ on my Pi Dog, if I remember right.
Yeah.
And one of the problems that I had was otherwise I would do all of their just song and dance to get all the software into it. And some things wouldn't start. They just wouldn't be, I'd reinstall it and then it would work. But then something else over here might not work. So getting them all to work was a little bit tricky. I hope they fix that later on. But because it's I hope to run the Pi Dog this May.
So I'm wondering if I can run the Raspberry Pi on a power supply and run this guy on a separate on the battery.
Yeah. That's an interesting idea. I mean, at least for test. Oh, you want to see it go for days without a glitch.
Yeah, I want to see it run, to run the competition without a glitch. Sometimes it'll run and it's fine, and other times it'll glitch out.
Yeah.
So much so that I'm switching my approach using a camera instead.
Yeah.
So it needs to be able to work. If it can't work,
I was using I'm using a powered hub to run power to my LiDAR and camera and stuff.
That's actually a good idea, Mike. So there you're using one of your buck converters to power the hub, I assume.
Right.
Yeah.
Every tiny hub I find that's like 4 or 5 inches long comes with a great big long USB cable on it. With a 6-foot cable. And
go to power it up.
You're trying to find with a 4-inch or 6-inch cable, or even better, a short.
Yeah, mine's like 2 feet, but yeah, I still have to wad it up.
Yeah, I really have trouble with USB.
I could cut it.
Cables, because even the short quote 6-inch ones, they really look nasty when they go into 2 adjacent ports, because that's all you need. So I don't know. It would seem like, these little ones that go like up and 90 and back down, that type of connector, where it's a connector. It's not a cable. It's a connector that you stick in and it goes up and does a little 180. Would be really neat, but none of them ever fit. So
I bought a couple of these little USB boards.
Yeah.
And that's what I was planning to use to, you can see.
So what are those USB-Cs?
No, those are USB A's.
I think they're A's, yeah.
Yeah,
Okay,
a male and a female. And it was basically to connect the board, and I could power it from a separate 5-volt power supply.
Yeah.
Basically, so you just take the ground and the data connections, and then a separate 5-volt power to the female port, and then power up whatever you wanted. That was my answer to the little Raspberry Pi hub.
Well, I did, I did show you guys a while back the thing from AliExpress, which was a USB cable tester, which it's only about $1.50, okay? But the thing that was really good about it was let you quickly separate your power only cables from your power data cables. Especially when you start getting the little short cables, which often come with accessories and stuff. Most of them are just power cables.
You should be careful with those now, because you're going to order one and find out that your $1.50 board or $1.50 cable tester is now going to be about $150 by the time duties and taxes or tariffs are.
Well, I'm afraid that it'll go into customs, where it'll be stuck there because people won't figure out what it is or something. Anyway, but you can get them out. You can pay more than that and get them on Amazon, if you know. But
I've been having good luck with like Tom mentioned, AliExpress Choice. So to the point where I'll pay a couple bucks more to get Choice but you have a part in your hands within a couple weeks.
Yeah. Well, I will say this. So far, things probably haven't kicked in, but I haven't had any problem with AliExpress yet.
Yeah, me neither. I just ordered something today, and there was no indication that there's going to be a hefty tariff on, anything.
Yeah.
So.
So I'm, I think it's still valid vendor right now. And they always have the interesting crap first, Unfortunately, some of it's crap, and that's you end up finding that out. Like, Paul, we talked the other day about, okay, so we get this robot, how do we power it? And I told you that I was going to do two 18650s.
Yep.
And we said, well, and I was thinking just pop them out and pop them in. Well, it turns out that that's really pretty hard to do with most 18650 battery
holders.
Yeah, battery holders are they're really meant to be put one in there and leave it in there. But I found some units that I'm going to try. I'm thinking I'm going to create basically another custom PC. I've got the holders, the PC holders for 18650 coming, and I got this module. It's a BMS, and it charges at about an amp, and it's 2S, and it has balance. So that would be really nice if it works. And what I've seen sounds like it would. The one thing I don't see it having is it doesn't have a low voltage alarm. Otherwise, if you just discharge your battery forever, okay, you can do that, where you don't want to have your battery go below 3 volts. So that might be another module that I might have to kick into this board design. So what I'm trying to do is have two mounted battery holders, a fuse, and probably this module, this module I had, and a connector, and just put it all together into a package that would, fit underneath the robot, basically.
You sure it doesn't have undervoltage? Because just like, it's not really a BMS if it doesn't have undervoltage protection.
Well, it has undervoltage protection in the sense that if you charge it, otherwise, if the output is hooked to the battery and also to the load, then there's no way it has undervoltage protection. Okay.
You might want to double check that. All my BMSs have both undervoltage, overvoltage, and overcurrent.
Yeah. And
well, how does it stop if the load and the battery are connected to the same terminals? How are you going to? Huh?
Don't do that. The battery.
Well, I'm saying it will be. I mean, on the module I'm looking at, that looks like that's the way it is. The output is common with the battery protector.
Okay.
It does say it's low voltage. Maybe I'm reading it wrong. These modules come with, like zip
zero documentation.
And then so I'll find out.
Yeah, you may end up doing a little bit of re-engineering just to find out, but all of mine, the battery and the charge connections are separate. They're not the same.
So like you see here, this is.
Are they 2S? Are they 2S, Tom?
I have bought 2S, 3S, and 4S, and they're all the same.
Yeah.
Okay.
And so you got a battery plus and a battery minus terminal, and then P plus and minus go to the, I believe, to the system. And I don't remember where BM goes. But yeah, they should. You never hook. It's not a BMF if it can't interrupt the current draw from the battery.
I'll have to look at this. This is a charger.
That's right.
This is a charger also. So
sure.
So it should be able to charge it. I want a board that charges and manages.
Yeah. Yeah, have another look at it, or we can look at it if you want, if you tell us
Yeah.
what model it is.
Yeah, I can
Yeah.
tell you. Let me go. I think I got it written down.
Oh, BM is meant to be MB, and it's the midpoint between the batteries. So yeah, it does the balancing.
Maybe battery midpoint BM.
The other interesting one, working on the Sunfounder board, come with a battery pack and a 3-pin cable. This guy, battery pack with the power wires, but the 3-pin cable is identical to the 3-pin cable.
Yeah.
So I've been running it off the larger battery.
Yeah, and they do that so it'll plug into standard charges like the Electrofly for for hobbyists.
Yeah, and it's working. It's working well to charge the battery. I'll bet a lot slower, but out of curiosity, I said, okay, I'll put it on my little charger.
I'll have to go
Without
look
the-
and see what it is, but this is what it looks like. If you can you see anything there?
Yeah, you're a little too close.
Let me see
You're out
if
of
this
focus.
helps.
Yeah, you're still too close. You're too close. Too close.
The thing that I'm concerned about is it could potentially have the battery separate. You can see here there's a plus and minus, and there's 3 holes here. Now the problem is I thought that these 2 of these holes were tied to the battery. I don't know if you
Can't see it
The
at all,
advantage of
Doug.
it,
It's
you know, the
entirely out of focus.
idea would be you'd charge it up, and we'll
Do you have a
see.
part number for
It
it?
did
Doug?
say it had low voltage, but in my mind, I couldn't figure out how they were doing that. So we'll see.
If you have a part
Yeah, I'll
number
put the,
to an Amazon page or something.
yeah, unfortunately, it's on my other computer, which is in the other room.
Okay.
Let me see. Let me do this. I'll be able to do this. Oh, God. They've made logging on to things so hard now. Oh, okay, let's see if we got worse. Oh, no, I have to sign in.
Tom, have you played with OpenBot anymore, or
No, I've
lost interest?
I've been working on my line tracker to the extent that I've had time. There's been too many other distractions in the last couple of weeks. One of them I thoroughly enjoy. I've had a lot of involvement over many years with our regional and national science fairs, and I still do. I still help them out a bit. So I got a chance to look at a large number of the engineering and computer science projects to assist with the special awards pre-filtering. several days ago, and I got to admit there are some projects I saw there. If they pan out in this week's fair, they might be interested in doing a presentation to certain robotics clubs. They are amazing autonomous robots, I'll tell you, just fabulous.
Cool.
Machine learning and artificial intelligence add-ons for sensors on robots are extremely popular. Also, standalone artificial intelligence projects are extremely popular amongst even early high school kids in science fair projects. And I'm amazed at the kind of technology I see them using. In fact, I was cautioning the chief judge. I said, normally engineers tend to be older retired engineers who are judging. And I said, you need to validate that they know what machine learning and artificial intelligence is all about when they judge engineering projects, because these 13 and 14-year-olds certainly know all about it.
Wow.
It's amazing. Like the majority of them include some ML component. I'm just looking at abstracts at this point, but they look pretty impressive.
Wow.
Now we run a very large regional
like
science
that,
fair here. There's about 300 projects in this year's fair.
Wow. That's neat.
I thought maybe you were going to say, somebody had a cold fusion demonstration or something.
Oh, I did mention that. Yes, he's in the fair as well. I mentioned that one a few months ago. I got consulted on that one. So there's one kid who's built an underwater ROV, which is intended to swim like a green sea turtle. And he's done all the design and modeling and construction work to make this thing swim using fin motions. The intent of the project is to go out and look at coral to see whether the coral is diseased. So it also has GPS navigation for surface movement and IMU navigation for underwater navigation. And it also has machine learning and an underwater camera to use to track and identify the state of the coral it finds. The project is phenomenal.
Wow.
He claims to have it all working. We'll see.
Yeah, I don't know if you've seen it or not. There's a PBS special. They basically made, several different models of, I don't think they were autonomous, probably more RC controlled, but everything from turtles to monkeys to, you name it, they've, had a little model for it. And they were accepted by dolphins was another one, I think. They were accepted by whatever animal they were, snooping on or spying on. And it was, pretty much amazing. They all had cameras in them. On like some of the penguin, I think rookeries is what they're called. They even had rocks with cameras in them to kind of blend in with what was there, and really pretty amazing to see it all. And they even looked realistic, as the way they swam or went through the water. But
yeah, Doug, you would hook the battery up to B+ and B-, and input plus and minus would be what you would hook to your load, and you could also put your charge voltage on there, or you could get put a charger into your
Okay, I see what you're saying.
input.
Okay, see, I think now the plus and the minus are actually the power are similar to the power to the USB-C. Okay, they're not. I don't think they're the output. And you see, if you look at the fourth picture down, you can see on the back side, it's not clear to me. You see, it looks like they have two of them together on both sides, two on the B plus and two on the B minus. And the BM is the balance.
Yeah.
Are you showing us a picture? Because we only see you.
Oh,
Click the link that Doug put in the chat, and
Yeah.
it'll take you to the Amazon page, and we're looking at the slide. But no, you don't hook the load to the battery. You just don't.
well,
Look
that's
below
what
the
I'm.
B plus and B minus.
Well, that's what I'm saying. I'm not sure this one's going to be a good one because I think
No.
that's what they do.
It'll be fine. It'll be fine, mate.
And I mean, it does say it's under voltage protection, and that's really what you want because you would like it to stop the load. You
Yeah.
know, you want to stop the
And-
load if you're
And
doing
so you hook the load to VN and ground, and you hook the battery to B plus, B minus, and that middle BM.
Yeah,
And then when it's running on battery power, the BMS passes battery voltage through from B plus and B minus to VN and ground to drive the load. And then when you hook your USB-C up, then it'll charge, pushing power back into B plus and B minus, and also feeding VN and ground.
okay. Yeah, I pulled one out of its plastic, and I did check to see if the voltages, because this is actually can be made if you give up balance. If you give up balance, you can actually make it 3S. But I didn't want to do that. I wanted to have a 2S with balance.
Mm-hmm.
And so anyway, I'm thinking of using this module, and like I say, a fuse.
Yep.
And two battery holders, make a custom PCB board for it. So it's just all one module. And that, and also mounting holes, something that a lot of times we forget, a couple of mounting holes. And that way we could have it slung underneath the small battery, the small robot.
Yeah, no, this should work. This will do under voltage.
Yeah, I think was confused. I see what you're saying. And I was confusing VN to be the 5 volts. And
Right.
it is. If it's plugged in, well, no, that's the thing I have to check. If you plug it in and it's 5 volts on VN, then it's not 2S.
Yeah, no, you'd want a higher voltage than 5 volts on VN. You'd put like
Right. Yeah, it should be what I'm trying to say is it's supposed to be able to charge with the resistors that are on this board. I did find some better documentation. And the way this one is set up, it's supposed to be able to charge at about 0.9 amps. Okay. Which is fine if you get it on, if you're just continuously charging for like troubleshooting. But if I plug in 5 volts into the USB, I should see 8 volts, 8.4 volts at VN to ground is what you're telling me.
I think if you plug USB-C in, I think they're expecting that it's one of those, what do they call the USB-C with the adjustable voltage? QC fast, Type C access QC fast charge will automatically adjust the charging voltage. So it'll be higher than 5 volts.
I'll have to check. I didn't test it on a, I didn't test it on a quick charger. So I'll have to see that. I do have those, so I could check it.
There doesn't seem to be any evidence of a voltage doubler or tripler on that circuit board. So
Right.
yes, it'll have to be using a QC charger to get the higher voltage.
No.
Otherwise, otherwise it won't.
That inductor is being used for the boost.
Okay, I was looking for the
2R2.
inductor. I didn't notice it.
It's a 2R2.
That's a resistor, isn't it?
Nope, that's an
Oh,
inductor.
okay. Okay, good. Good
Yeah,
note. Good
okay.
notice.
Okay, because that one, I did check. Otherwise, I did plug it into 5 volts,
Okay.
and I did check the B plus, the B minus, and it was 8.4 volts.
Oh, good. Good.
Okay, so I know that. But like I say, it's not clear to me where the load goes. And the only 2 places it could go are V and ground. But I thought that those were hooked up to the 5 volts of the USB-C. So if that's the case, then what I told you earlier is true. They don't, I mean, it says that it has low voltage, okay? So maybe I just didn't think it through, but we'll have to see.
So there's a data sheet in Chinese. If you Google that chip that's on it, the IP.
I think that's, you
26.
found, oh, okay. Oh, that's,
And it has an inductor on the output. So it looks like it does have a boost,
yeah.
a boost function or a buck function.
Can you go ahead and
can
you put that link in to that?
Yeah, let me see if I can find one.
No, I can just use Google to translate.
Possibly a chip or module with 2,326 as part of its identifier.
Quiet.
Mention of an inductor on the output strongly suggests it's a switching regulator capable of
Google went crazy.
bucking voltage. Here's a breakdown of what that implies. DC-DC convert.
Stop. Sorry about that.
If it is, this is a pretty cheap module if it works, and that would be kind of nice.
Well, I'll stick the link in, but it's a lot of the data is in Chinese, so it's not going to be. You can get the gist
Well, you
of it.
just use translate. Yeah.
Really? Will it translate Chinese?
Oh yeah.
Really?
Yeah.
Wow.
Yeah. It does usually a pretty good job.
Wow.
In fact, I use it to, when I get Chinese code with all the comments are in Chinese, I usually do that.
Wow.
Yep. Oh man.
Yeah, I think I guess before translators came out, there was a tattoo that looked like Chinese characters, and it meant totally something different than people thought it meant. So went through all that trouble just to get a tattoo that didn't say what you thought it said.
I'm dropping off. Bye bye.
Okay.
Good night.
I'm out of here.
All right. Beth, I'm real excited about your haul. I want to see how that comes out.
Night, guys.
Oh yeah, sure.
Yeah, I think I'm gonna head out too.
Okay, Ray.
Yeah. Could be
We'll
time
see
to
you guys
wind it
later.
up. I don't know.
Actually, Doug, that's impressive. This thing includes doubler and tripler capabilities in that chip, along with charging circuitry. That's pretty
Yeah.
cool.
Wow.
It's pretty efficient. Switch mode regulator. Huh. I got to watch for that.
Well, for some reason, I'm not getting it to detect the language.
No, I didn't see a translation happen as well, but there's enough information in the graphs, for example, which are mostly English. Numbers are always numbers, the universal language. And you get enough clues from what's there to figure out most of it. That's pretty impressive. Or you could probably screen scrape it and drop it into Word and translate it inside Word or something like that. Anyway, that's quite a find, actually. I didn't know they had those.
Yeah. Well, like I say, I think, you know, okay, here it is. They even have a you know, what do you call it? Typical design or suggested design.
Yeah.
Yeah.
But I admit I haven't seen any indication that it does over voltage and under voltage detection, but presumably it does. That's the part where I would like to see a translation.
Yeah.
But the Amazon page claims
It does, but you got to be careful. You never know what it's going to do, you know. I'm trying to see if there should be a parameter which says something like voltage dropout or something like that.
If you look on page 6 of the chip schematic, there's what I suspect is a good internal schematic that indicates that there's UV set point and OV set point, so under voltage and over voltage set points.
Yes, there is, but I think the voltage set point is the 2S. Okay, I believe, and the IS is the charging current.
Yeah,
I did find that out. But you see where it says VN under voltage set?
Yep.
That's where, see, that's VN. Sounds like that VN pin might be not connected to, might not be connected to the
battery.
USB-C.
Yeah, it may have something to do with the voltage doubler.
Yeah. Anyway, I'll have to do some more checkout, but be real interesting to see if I can figure out why I can't get this to translate. It says it's trying to finish it. Launch
yeah,
it.
the PDF, I think, is maybe the problem, not a web page.
Yes.
Well, no, PDFs usually work pretty well. No, I don't know. Yeah, I don't usually have any problem. Let me see. You tried. I just said it was trying to do some sort of, yeah. Okay, and that kind of worked. It was looking for an update. We want to change it into English. Okay, done. Oh, come on. Used to have a little switch hour. Where you could just Okay.
Okay, I'm screwed now. My translator wants to translate to Chinese.
Yeah, I know that. I just got that fixed, but I'm still not getting it.
I'm done.
Where-
Guys,
no,
I
where
gotta
this-
go to bed. It's late here. So,
Yeah, where it doesn't work is when they put the image as an image and not as text.
yeah.
So
I-
anyway,
See you
all
guys.
right, guys. Hey, well,
All right.
anyway, I'm glad I talked to you guys. You helped me out, figure out what I might be doing wrong.
Okay. Well, gentlemen, I'll bid you good night.
Yep.
See you
Bye
on Saturday.
bye. So.